Hi, I'm Josh Hackett, hydrogeologist here at the Oregon Water Resources Department. Today I'll be talking about measuring water levels and conducting pump tests. We have two programs here at the department in which CWREs or other qualified folks are measuring water levels. The first is our permit condition program, and the second is our pump test program. In our permit condition program, we've typically been requiring annual static water level measurements on new permits in recent years. And then in our pump test program, we require a pump test on any well on a water right that has a priority date that's greater than 12/19/1988 before we issue a certificate. And we require a 4-hour minimum pumping time on those. Now, the water level data that's collected as part of those programs is integrated into our databases here. And in the groundwater section, we use that data to do many things. First, we use them when we're reviewing new applications for groundwater rights. We look at is there adequate supply for proposed use, so are water levels declining in the aquifers that we're looking at, or are they staying the same? Are they not declining? We also look are they over appropriated? Is there too much use going on? And then we look at the impact on surface water supplies. Next, we use those in well-to-well interference complaints. So we look and see, is there a problem with the aquifer here? Are water levels declining in the aquifer? Or do we have a well that's inefficient and we're just having problems in an individual well? And we also look for same source in water levels. Are the heads drastically different in these wells, or are they producing from the same source? And so we use current water levels that are coming in. We also use historic water levels. And then lastly, we use these in bigger groundwater management decisions, such as classified areas. Do we need to create some groundwater limited areas because we're running out of water in certain places? Do we need to withdraw areas, or do we need to create critical groundwater areas? Finally, we use these when we're looking at conjunctive use between groundwater and surface water. So these programs, both these programs, are highly important to the department's data collection effort, and obtaining the highest quality data is of utmost importance to us. So with that in mind, the goal of this talk today is just to provide some information that hopefully makes your life easier when you're out measuring water levels and conducting pump tests. Now here's a brief overview of what I'll be talking about today. In the first part, we'll be talking about well identification. I'll give you some tips on how to properly identify a well. This is the first part, and the most important part is to ensure that you're measuring the correct well. Next, we'll get into water level measurement. I'll talk about what water levels tell us, what information it gives us, what water level status is, some measurement methods that we use to measure water levels, how to get good water level data, some miscellaneous problems you may run into while you're out there measuring water levels, and then some tips on how to get around those problems. In the last part, I'll get into pump tests. First, we'll talk about what a pump test is. Then I'll talk about what it tells us. We'll talk about some of the requirements for pump tests that are conducted for the department, some exemptions, certain discharge measurement methods, and then water level measurement methods as well. I'll give you some examples, good pump tests, bad pump tests. Then we'll just look at some of the pump test forms, and finally we'll finish off with some tips on how to conduct a good pump test. Well, now let's talk about how to identify a well. Identifying a well correctly is important because water levels are of limited value if the well construction is unknown. So if you're at a well at a property where there's two wells and you think you're measuring a 300-foot deep well, but you're actually measuring the owner's 100-foot deep well, the water levels that you get will be misleading. So it's of critical importance to be measuring the correct well. At the department, we use driller's well logs and well tags to identify wells. The well log is something that the driller fills out during the drilling process. It describes the materials that he drilled through. He also describes the casing diameter, the seal depth, the total depth of the well, those sort of things. Well tags, we've been requiring tags, which you can see here. This is a well tag. Since about 1995, we've been requiring those on new wells or on wells that drillers visit to either deepen or alter in some other way. So you can take both of those. Sometimes a well will have a tag and a log, and so life is easy there. We know which well we're talking about. In some cases, a lot of cases, wells do not have tags yet, and they only have logs, or in some other cases, wells do not have either. So what we can do, though, is use some independent information when we're out there in the field to help identify these wells. We can try to sound the depth, put your water level probe down and look for the total depth of the well. That'll give you an idea. You can also look at the casing diameter, and then you can ask the current owner, maybe this well was drilled for somebody else. Who was the original owner? You can use that information to try to tie back to a well log to get the proper log. You can also use a GPS location. You can submit that to somebody in the groundwater section, and we can try to help you out. Contact us anytime if you have some questions about which well you're actually measuring. And I provided a map at the end of this presentation that shows it's a current map of our hydrologist or hydrogeologist by basin, who's working where, basically. Finally, what you can do is ask the owner some questions about the well. And here's some example questions. First off, do you have more than one well? A lot of times you'll be out there thinking there's only one well, but there could be another well somewhere on the property, and that's the one you may need to be at. You can ask specific questions if you know something, if you have a log. Is this the 350-foot deep well that was drilled in 1997? Another question is, has this well ever been deepened or altered or anything like that? And if so, by whom and when? You can track down those logs and tie those to the well as well. Finally, we already talked about this, but who is the original owner of the well? These are just some example questions that should help you get closer to finding a log for the well. Okay, now we're going to talk about water level measurements. First, we're going to talk about what water levels tell us. First thing is how much water is in storage. What's the water level in the aquifer? You look at that over time, and you can see, is storage changing? Is it increasing? Are water levels going up? Is it decreasing? Are water levels going down? You can also get an idea of, are these natural changes? Are they due to climate cycles? Or is it related to changes caused by pumping? Is there an increase in pumping in the area that would be causing water levels to decline? Or is pumping decreasing in the area and water levels are going back up in response to that? It can also tell us about the direction and the rate of groundwater movement. And finally, how groundwater interacts with surface water. Here's an example of changes in aquifer storage over time. This is a well just outside of Wilsonville. And what we can see here is that there's a decline from 1960 to about 2002 in water level. So water levels are going down. That's in response to municipal pumping by the city of Wilsonville. In about 2002, the city stopped pumping its wells and started getting its municipal water from the Willamette River. So what we see in response to that then is a rise in water levels, an increase in storage. And water levels to this day are still responding to that reduction in pumping by the city. So water level status, that's just basically what's happening to the water level in the well while you're measuring it. Is it static? That means it's not moving up or down. Nothing is happening. Is the well pumping? So your water level is going to be falling. Or is it rising? Was the well just pumping and now the pump has turned off and the water levels are coming back up as a response to that? Falling water level could be a response to a nearby well that's pumping. So it's drawing the water down in the well that you're measuring. A flowing well is an artesian well that's flowing at land surface. You run into those every now and then. And finally, a dry well is your well have no water in it. These are all possibilities. Why do we care about that? Because static water levels are what we're looking for when we're looking at changes in aquifer storage over time. you want the water level not to be affected by anything else that's going on. So you need to ensure that it's static. And so there's ways to tell if you go out to a well whether or not the water level is static. So let's say you come upon a well and you go to measure it. You get a water level, you think it's static, but you're uncertain. You don't know. It could have been pumping recently, or there could be nearby pumping going on. So what I do is I get my water level with my tape, and I just pull it up a couple hundredths of a foot, and I wait for about 5 minutes. And if the water level hasn't come up that couple hundredths of a foot in 5 minutes, I know that it's static. But if it does, you know that the water level is recovering from some nearby pumping, or the well itself had just shut off and you didn't know about it. Here's just a diagram looking at a cross-section of an aquifer about water level status. What we see on the left here is a static water level, not influenced by any pumping or anything that's going on in the aquifer. In the middle here is the water level when the well is pumping. You can see the water level in the well is drawn down in response to the pumping, and there's a cone of depression has formed around the well. And finally on the right we see a water level that's recovering. The pump has shut off, now the water level is coming back up, and your cone of depression is shrinking in response to that. So now we're going to talk about some of the typical water level measurement methods. I have several examples up here which I'll talk about. First, what we have is called a steel tape. This is a tape that was very popular before our electric water level tapes were invented, and it's still commonly used today. It's very good for shallow water level measurements. It's a calibrated tape, so there's markings on the tape. You can't see them very well here, but it's marked about every hundredth of a foot. And what you do with this sort of tape here is you take the chalk, you mark it on the end of the tape here up to a certain footage, probably about 5 feet. You send that down the well, and then at some point where you think your water level is close to it, you grab, dip to the well, and then pull up. And so you know where your hold is here. Let's say it's 50 feet, and we know when we pull this up that about 2 feet of the chalk came off. So our water level is 48 feet below our measuring point there. These are, like I said, these are good for shallow water level measurements and for static water level measurements. The problem is, if you're conducting a pump test, it's hard to chase water down a well while using these, especially if there's a lot of turbulence going on in the bottom of the well. You have to continually pull this back up to re-chalk it and then put it down again, and if there's a lot of water moving around, it can kind of rinse the chalk off and give you a false read here. But this is good for shallow static water levels. Next tape we have here is a calibrated E-tape. An E-tape is basically, it has 2 leads at different heights, and when both of those leads are in water, it completes an electrical circuit and sends a beep up to the unit here. It sounds like this. This tape we use in wells that don't have pumps. This is a good one because it's calibrated and it's got markings also every hundredth of a foot. And so it gives very precise water level measurements. We don't like to use this in wells that do have pumps because if it gets caught or something like that down the well, you have to cut the tape. It's very hard to get it back out. And so that's a big issue, and these are expensive. Another issue is the weights that come with this are kind of large, so you may not be able to get them into some access ports. But this is a very good tape for wells that don't have pumps. Next is another variation of the electric water level tape. It's a coaxial cable. Same principle, also has 2 leads. But in this case, it's not calibrated. It's a kind of a thin line here. It's got markings at 5-foot intervals. So here's the first mark at 5 feet. So what what you would do with this is stick it down the well, get your measurement. You get your measurement at some point, you pull it up, and then we use just a standard tape measure here. This one is actually in hundredth of a foot, and we just measure down between those 5-foot intervals to see what our water level is. So this is the one that we use most of the time in wells that have pumps or when we're conducting pump tests. This is good because it's a narrow diameter, small diameter, so it can go down wells a lot easier and get into smaller access ports. Now something that we do is we actually order these from a company called Waterline, Virotech. They're up in Bellingham. We order them without the weights on. We put our own weights on. So these weights are just copper wire and surgical tubing. You can get the copper wire at Home Depot or anything like that, and surgical tubing we usually get at Weimar. Now the advantage of these weights over these heavier weights here and these larger diameter weights is that these weights, we string them to slip off very easily. So if you get caught when you're down the well, all you have to do is pull and the weights will slip off the line and you won't have to cut your line. So it's kind of our motto here is it's better to lose weights than line. It's expensive to replace the line, but the weights are relatively inexpensive and they just settle down to the bottom of the well and don't cause an issue. Our third method over here is an Airline. Now this is not the Airline itself, this is actually a compressed nitrogen tank. And this is a pressure gauge. Now if we can look up to the screen here, we have a diagram of an Airline here in the well. An Airline is essentially a metal or plastic tube that extends from the top of your well down a certain distance into beneath the water level. So you know the total length of your Airline, and so you have some water sitting up in your Airline, and what you do then is you pressurize the Airline, which we do with either compressed nitrogen or some folks use compressed air. But we use these because they're very portable. So you pressurize the line to expel all the air, or all the water that's in the line, excuse me. Now, you know the amount of pressure, because you're measuring it with this pressure gauge, that it took to expel all of that water. And the pressure then can be converted into a footage. There's 2.31 feet of water per PSI, pounds per square inch. So convert that to a footage. You know the amount of water in feet that you had to expel out of your line. Subtract that from the total length of your Airline to get your water level below the top of your Airline. And we like to use these when there's no other access into a well or on water levels that are very deep or extremely difficult to measure. Now the problem that we have is that the accuracy of these is not very good, because typically here's a 100 psi gauge, and it only gives its accuracy is only to half a psi, and half a psi is a little over 1 foot. So the resolution there of our measurement is only to the nearest foot, and we typically like something that's about 1/100 of a foot, so it's kind of way off. But it works, to get a general idea of where the water level is. Okay, so let's move on. Now here's just a diagram of a well. We also have an example up here. What we're looking at is actually now measuring a water level. So if we look at our diagram here, we have our well. It's above land surface here. Here's our casing. Oops, excuse me. Here's our casing. Inside the well, we have a liner. Here's our seal that extends down to some depth. Our water level's down here, and here's our submersible pump. Here's the measuring point on the well, and here is our E-tape going down the well. Now the measuring point is some point on the well where you're measuring from that's above, it's typically above land surface. So in this case, this will be our measuring point. This is our well here, this is our casing. We have a 6-inch diameter casing. We have a split seal on top here. Here's our discharge pipe where our water is coming out of the well. Here's our hole for our electrical wires. This is a part of the seal that would be on the well. And here's our standard well tag. Now our access, our measuring point is here near the top of the casing. So it's relative to land surface. We're going to call the top of the table land surface here. So we measure from land surface up to the measuring point. And we're looking at about 1.85 feet. So that's the height of our measuring point above land surface. So if we're measuring the water level, we just come in, send our tape down, get our water level at some point, pull it up, make our measurement here of where our water level is, and then we take that, we subtract 1.85 feet from it, measuring point height above land surface, and that gives us our water level below land surface. Now if our measuring point is below land surface, then we add however far our measuring point is below land surface to the water level. So it's as a standard there, our measuring point is positive above land surface and negative below land surface. Now let's go into some tips about how to get good water level data. The first thing you want to do before going in the well is make sure that the contacts on your tape are clean. I don't know if you can see this here. Here's our upper contact here, and our lower contact is down here. So when both of these are in the water, that's when you get your beeping sound to let you know that you're at the top of the water there. There's nothing worse than going 200, 300, 400 feet down, not getting a signal when you think you should be, pulling it up and realizing that your contacts are not clean, so that's why you're not getting the signal. So we kind of, we take a little knife or something and kind of scrape them off just to make sure they're clean before we go into the well. Another thing that's important is to know the well construction. If you have a log, read the log, look and see if there's a liner. Sometimes a liner can be 20 or 30 feet below the top of the well. So it's important to try to, when you're measuring, try to go down near the center to try to get inside the liner. If you're outside the liner, you're not going to get a measurement. Also know the total depth and the pump depth, so that way you don't go too far and go past the pump and risk getting caught up in the pump. Also, if you have an expected depth to water, what was the water level on the well log? Or are there nearby wells with water levels that you know of? And finally, we talked about a little bit earlier, is to string your weights to come off easily. It's better to lose weight than line. So, now if we're talking about actually measuring the water level, going down the well, you want to, while you're going down the well, you want to reel out slowly. So if we're going down here, we want to be reeling out slowly. We want to be feeling our way down the well. You can feel the weight on this, and you want to be able to feel if you're hitting any obstructions in the well. You got to make sure that you're monitoring the line weight there. Make sure you always have weight on the line. If you lose weight, you know that you're probably stuck, you're sitting on something, and you shouldn't put out any more line because it has a better opportunity to get tangled up in the well there. If you do feel something, just shake it. You can feel that the weights are kind of moving freely there. If you're stuck on something, they won't be kind of moving back and forth as easily. You'll know that you got an issue. If you're hung up, something that we like to do is kind of raise and drop. raise and drop. If you drop quickly past that point, a lot of times you can get by without an issue. So that's just a technique that we like to do. Sometimes you need to add extra weight. You're going down a long way, or there's an obstruction that you can't get by because your line's not heavy enough. So we put a few extra lengths of copper pipe on there, or copper weights. And then finally, try another way in. If we look at this as an example here, this is our main access port. But on the split seal, we can actually remove a bolt and try to go in another way. You can remove typically one of these bolts and not have any problems. So we'll try to go in that way. Maybe the liner is set off to the other side or something, so we're getting stuck, can't go down this way, or just not having any luck. Always try another way, and usually you can have success. So on the way out, we want to kind of reel up slowly. You're going to be feeling the whole way. You don't want to bring it up as fast as you can and then get caught and really hanging up on something and end up having to cut line. Just kind of take your time coming out and feel your way up. If you get hung up on the way out, don't yank on it. Don't yank on it. Just kind of shake it right there below where you're hung up. Shake it, see if you can end up getting by. If you can't, and you need to pull off the weights, just kind of pull up slowly until you feel the weights come off, and then you can pull out. At least you'll still have your line. And then you just want to note where your hold point was. If you end up having to break line, just note where you had to break it off. There's various problems you can run into measuring water levels. The first one is what's called cascading water. That's water level from an upper water-bearing zone cascading down the well. That causes problems with your contact here. If it's hitting, if it's hitting both contacts, you get this chattering signal, beep, 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 beep. You think you might be in water, but you're not. It's just cascading water that's coming down and hitting this. You want to keep your leads separate, a foot to 18 inches. That tends to help a little bit. Another thing that we do is take just electrical tape. We make a little shroud over the top of this, kind of like a raincoat, that's kind of angled down. So that way, when water's coming down, it kind of keeps this guy under cover. And really, that tends to help a lot of times. Another thing you can do is on here. There's a sensitivity meter here, which is how sensitive this is to the electrical conduction. And so if you turn that down, that tends to reduce a lot of the chattering, and that helps. I find that helps a lot. And then, if you're still having problems and you just can't get it without the chattering, just note that in the water level. That's beneficial to us to know that there was issues while you're out there. Another problem is oil on the water. If you're out measuring a large irrigation well and there's a big turbine pump sitting on the top of the well, those are typically lubricated with oil, and sometimes a lot of oil can get on top of the water level in the well. So as you're sending your tape down the well, that can get coated with oil, and the coating doesn't come off until you could be several feet into water before you get your signal back, just because it took a while for that oil. And then if you're going through it a bunch of times, you could stir that oil-water interface up, and that also causes problems. So what we like to do is go down till you get a strong signal, then shake the line down there, try to get all the oil off, get it clean, and then pull it up. You should be hearing the beeping the whole time, and then grab it right where the beeping stops. That's typically the top of your water, the bottom of your oil interface right there. So you're bound below, you're shaking, you're pulling up, it's beeping, beep, 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 stops. You pull it up slowly, and there you go. That's your water level. Typically, that works for us. We like to repeat it more than one time, see if we can get the same value. Let us know that's a good water level measurement. And then once again, we'll just note oil in the comments section. A few tips here, just at the end. You want to keep your equipment clean, sanitize all the time, so you don't want to be going into multiple wells without cleaning your E-tape. So we have a dilute bleach solution that we spray after each well. We don't want to contaminate other wells, potentially iron bacteria or something like that you might run into out there. Make sure you record all of your numbers very carefully while you're out there. Double check your calculations. I know that happens to me a lot, is just trying to go too fast and making a wrong calculation. So you got to double check them, make sure I'm doing the right thing. And then finally, most important again, is make sure you're measuring the correct well. Alright, now let's talk about pump tests, the main event here. First, what is a pump test? Here's the definition from our administrative rules. It's a controlled procedure in which water is withdrawn from a well at a constant rate for a specified period of time, in which the water level in the well is measured at specified intervals before, during, and after pumping. In a sense, a pump test is a controlled field experiment where we're trying to control as many variables as possible. The pumping rate needs to be constant. We need to be measuring at specified intervals. That's what a pump test is. It's not just a test of the pump, but it's a test of the aquifer as well. So some of the information that's provided by pump tests is first well performance, the yield, drawdown, the efficiency of the well. Next is aquifer transmissivity, which is related to the permeability, how easily water moves through the aquifer. And some other things that you can get out of pump test, you can extrapolate to estimate future drawdown, what you might expect at that same pumping rate over time. An estimate of well interference. You can look at drawdown at a distance from the current well that you're measuring. The degree of connection between aquifer and stream. And then the presence of any hydraulic barriers. So here we're looking at the phases of a pump test, the three phases. And what we're looking at here is drawdown on your y-axis here, on your vertical axis, and your time since pumping has started on your horizontal axis. So negative time means we haven't started the pump yet. And what we see is we have a pre-pumping period where we're measuring static water levels. There's no drawdown yet. And then as soon as you turn the pump on, you have a rapid rate of decline here, a rapid rate of drawdown initially, which kind of tapers off towards the end of the pumping period. And then as soon as you turn the pump off, you get a rapid rise in water level, which then tapers off as well in your post-pumping period. Here's the department's minimum test requirements for pump tests. First, your pump has to be off 16 hours prior to the test. You need to measure 3 static water levels within an hour before the test. Your discharge, we need a constant rate and as near as possible to the rate that you'll be using or that the well uses normally. So the permitted rate essentially. And you need to measure the discharge at the beginning of the test and then once each hour during the test. For the pumping phase, it has to be at least 4 hours long. For the first 10 minutes, water levels need to be measured every 2 minutes. Between 10 and 30 minutes, water levels are measured every 5 minutes. And then from 30 minutes until 240 minutes, you measure water levels every 15 minutes. Now, for the recovery phase, after you turn the pump off, it has to go at least 4 hours or until 90% recovery. So the water level is 90% of the original static water level before you started the test. So for the first 10 minutes, again, we're measuring water levels every 2 minutes. From 10 to 30 minutes, measuring every 5 minutes. And then from 30 minutes until the end, you're measuring every 15 minutes. Those were our requirements for the test, and here is what we actually prefer. And if we were out doing pump tests ourselves, or when we are out doing them, we try to do this way. Still keep the pump off for 16 hours prior to the test. So the next part, we try to measure static water levels every 20 minutes, 2 to 3 hours prior to the test. You want to kind of make sure or look at what's going on in the aquifer prior to the test. So are water levels actually static, or are they changing in the aquifer before the test? You need to know if there's any outside influences that are going to be occurring during your test. Discharge, constant rate, very important. We try to use the same rate during normal use. And then we try to measure discharge on the same frequency as water levels. And that could be difficult sometimes, especially early on in the test, where you're trying to get a water level measurement every couple minutes or every minute, and it's difficult to also read the flow meter to measure the discharge. It's a little bit easier if the flow meter is near the wellhead where you can see it kind of while you're measuring water levels. But if you can't get them on the same frequency, at least more than 4 times during the test is better. So for the pumping phase, once again, 4 hours. We'd like to measure every minute for the first 10 minutes. That's just because drawdown is so rapid during those first few minutes, and there's the potential that you may have some near well boundaries which would influence the drawdown. You may not see that if you're only measuring on 2-minute intervals. And it's more important, especially early on, to record the exact time that you get the measurement and not to the nearest minute or something like that. So if you're trying to get a water level at 2 minutes and you can't, and it's not until 2 minutes and 30 seconds, note that. It's better to have that, to get it at 2 minutes and 30 seconds, than to say that that measurement was actually at 2 minutes. It kind of messes up the data in that way. So from 10 to 30 minutes, we measure every 5 minutes, and then from 30 minutes until the end of the test, every 15 minutes. So the recovery phase, same as the pumping test. A lot of times you can get 90% recovery, especially in a very transmissive aquifer. There's a lot of permeability. You can get 90% recovery within just a few minutes. If that happens, we like to continue to measure until there's about 95% or even 100% recovery. We measure every minute if possible, and we're recording exact time for the first 10 minutes. And then measure every 5 minutes from 10 to 30, and from 30 to 240 we measure every 15 minutes. So there are certain examples where you can get exemptions from the pump test program. The first one is a multiple well exemption. So if you have multiple wells on the same water right or even on different water rights, as long as it's the same owner on the well and the wells produced from the same aquifer and they're within 5 miles of each other, you can get a multiple well exemption. So you just test one well and the others are exempted. Now you need to request that in writing to the department, and you have to supply us with the well logs. In certain cases there's complete exemptions from the program. It doesn't happen a lot, but if there's absolutely no way to measure the drawdown in a well, then every now and then we can give a complete exemption. That also must be submitted in writing. And we don't require tests for infiltration galleries or collector wells or wells that are greater than 36 inches in diameter or less than 30 feet deep. So we have some acceptable discharge measurement methods for our pump test program. The first one is properly installed and calibrated flow meter. That's what you'll see most frequently, flow meter on the discharge pipe. Also, there can be weirs or flumes, an orifice plate or a manometer. Those are kind of rare. An ultrasonic flow meter, you may see some of those. And then finally, if you have a low volume, low producing well, a volume and time method. Essentially a calibrated bucket and a stopwatch. Here's some picture examples of what I'm talking about. Ultrasonic flow meter up here on the left. That just uses ultrasound at 2 points along the discharge pipe. So here's a discharge pipe here. It uses ultrasound to determine the velocity of water between these 2 points. Then you can use the area of the pipe multiplied by the velocity to get your volume, your discharge rate. On the right upper part, we have the mechanical flow meter. That's our calibrated flow meter. That's the most typical one that you see. Our discharge pipe is this blue pipe here. It's showing a look into the inside of the pipe, which is a propeller there, and that spins based on the velocity of water going past it. It converts that to a discharge, and so our head up here is reading the current discharge in gallons per minute usually, and it also is a totalizing flow meter, so it'll tell you the total volume pumped as well beneath that, usually in acre feet or gallons or something like that. Finally, here's a picture. This is actually two of our department staff measuring, or actually conducting a pump test on two piezometers that we installed out in the Grand Ronde Basin. They have a pump here at land surface, and they're pumping out of this, and they're measuring the discharge with this calibrated bucket here and a stopwatch. These are low producing wells, so we're able to do that. And we allow this method on wells, if you don't have a flow meter, on wells that are produce less than 60 gallons a minute. So we've talked about water level measurement methods, the different equipment that we used. Now here's kind of the standards that we have for them. So on our electric tape, we need depth markings at least every 5 feet, which we have on the one that I showed earlier. So it needs to be accurate to 0.5% of the measurement interval. It equals about 0.03 of a foot. And then you need to report to precision of at least 1/10 of a foot. If possible, we like it down to 1/100 of a foot. Airline and pressure gauge, you can only use those for the pump test program if the depth of water is greater than 300 feet. And you have to verify the accuracy of your airline with at least one measurement by an E-tape. So you have to be able to measure the water level with an E-tape before we would allow you to use the airline as part of the pump test to make sure that your airline length is correct. And finally, the steel tape, which we also looked at earlier, we only allow those for static water level measurements, and that's just because it's hard to chase down pumping levels with the steel tape. You have to keep winding it up and putting chalk on it. So here's some examples of pump tests that have been submitted to the department. This is a good test here. So we have the typical pumping pattern here with the drawdown, excessive drawdown early on, which kind of flattens out, and when you turn the pump off, you get relaxation in drawdown, which then flattens out. This is just looking in linear time here. Now if we look in logarithmic time, so here's 1 minute, 10 minutes, 100 minutes, 1,000 minutes. What we see is a straight line. And so what this is telling us is that our drawdown per log cycle, so from 1 to 10 is a log cycle, 10 to 100 is a log cycle, 100 to 1,000 is a log cycle. For each log cycle, the drawdown is the same. So the drawdown should be the same between 1 minute and 10 minutes, and 10 minutes and 100 minutes. And we can use the slope of this line here, plug it into some equations to get the transmissivity of the aquifer. So this is really valuable stuff here, and that's why we like these good tests, to get a lot of information about the aquifer. Here's an example now where the pumping rate was not held constant. So you see the initial drawdown, but then you see, still during the pumping phase, a little rise in the water level. So it looks like what happened here is the pumping rate decreased. So we're not pumping as heavily, and water levels are responding to that. Water levels are coming back up because the pumping rate has gone down. And then perhaps the pumping rate increased a little bit again towards the end of the test. Now what happens then when we try to plot this up on our log scale is we don't get those straight line segments. So this is of little to no value. We can't determine any aquifer properties from this test. Same thing with this. This is just a poor quality test all around. I don't know exactly what happened here, but we had the initial drawdown, and then just measured a flat line here, and then a little bit more drawdown. And once again, it's unusable data. Here's our pump test forms. This is just a cover sheet that need to be turned in with each pump test. Just the basic information we're looking for: well owner, well location, information about the well, the water right information, who conducted the test, your measurement methods for discharge, water level measurement methods, that sort of thing. This is just the cover sheet, the upper part. Here's the bottom part of the cover sheet. You need to describe if your distance from any nearby water level or surface water sources, which could be influencing your drawdown data during the pump test. They need to describe your measuring point. Is it above or below land surface, and what's the height? These are your static water level measurements pre-test, and then your discharge measurements during the test, and then time the pump turned on and time the pump turned off. Now here's the data sheet for the pump test form. This is where you fill in the information during the test, your date and time, your time since the pump started, your depth to water below the measuring point, and then below land surface. In the comments here, if you want to record discharge measurements on a more frequent basis than just those 4 on the cover sheet, you can put the discharge here at a certain time. That's helpful to us. Also, you're supposed to do 2, 4, 6, 8 minutes measure, but if you can't, make sure you put the exact time in. If you get a measurement at 2 minutes and 15 seconds, put that in. That's also helpful to us when we're reviewing these tests. So finally, here's just some tips. Before you conduct a pump test, make sure you know something about the well system. You can go out to a well, and perhaps it's a big irrigation well, and the irrigation lines need to be pressurized. You should know that before going out or before you start the test, because if you turn the pump on and the irrigation lines are not pressurized, your discharge will decrease initially, and then it'll come back up while those lines are pressurizing. So that can definitely influence the test, have negative results. Also, where's the valve that regulates flow from the well? You need to know that in case you need to crank it down to maintain a constant discharge. These are important things to ask the owner. Just get familiar with the system before you start the test. And I've already said this several times, but record the exact time of the water level measurement. It's most important during the early drawdown time, where at 2 minutes, you could have something over here. Whoops, excuse me. You could have your drawdown could be offset, and that can interfere with the analysis of the test when we're looking at it. Here's just some links. I think this presentation will be posted somewhere online, so you can look at these links. But just to our pump test rules, our permit condition water level forms if you need those, our pump test forms, the well log database if you need to look for a well log, our water rights database, and then some water level data that the department has either collected or has gotten from other folks. Here's a map I was talking about earlier of our hydrogeologists by basin. So if you need to contact one of us, please feel free to do so if you have any questions.